I'm Anil Kumar. Welcome to my series of functions flexibility. Now, the idea of having this series is to understand how we can write one function in terms of another function. It finds huge importance in solving algebraic problems. Especially, this series is important for those who are going to take calculus in future. The question here is, express the circumference C of a circle as a function of its area. So, you know the two formulas, one for circumference and one for area, right? Let's say this is our circle, and what we are given here is that this circle has a radius of r. Now, for this particular circle, that area could be written as a function of r as pi r square. And you also know that the circumference can be written as a function of r as 2 pi r. Right? So both individually can be written as functions of this radius r. But let us say, if you are interested in relating circumference and area, how are you going to relate it? So that is the question which we are going to address. So in this particular video, we'll express circumference of a circle as a function of area. So we want circumference as something times area, right? So that means we will exclude r, or we will write r in terms of area, substitute here and get circumference in relation with area. So that we can do from here, right? So if I rearrange this particular formula, what do I get? I get area, let me write just area now, divided by pi equals to r square, or I can say r is area divided by pi square root. So I get relation of radius over area. Right? Now, once I get that, I can replace this in that function. So we get now circumference as 2 pi times this radius, which is square root of area over pi. Do you get the idea? So that is what we get. Now, in this particular formula, you will observe that circumference can be written as just a function of area. Right? So we could write this as circumference as a function of area is equals to 2 pi square root of area over pi, right? So that is one way of writing. Of course, you can simplify, correct? So if you simplify, you could also write this formula as circumference as a function of area equals to 2. If you take this is like square root pi over square root pi. Or you can take this pi inside, it becomes square, and then cancel with this pi. So you get square root of a times pi. So both these formulas could be used as circumference in terms of area, correct? You could do the other way also. That is to say, we could actually write, let me extend this question here, and let that be your exercise also. From here, we can write, we know circumference is equals to 2 pi r. We can rearrange and write circumference over 2 pi equals to r. Now if I replace this r here, I get area in terms of circumference. Let's do that part also. So we'll say area equals to pi r square. So I'll write this as c over 2 pi whole square, right? So independently we are doing it. So we could actually arrange from here also, but anyway, we are doing it independently. At times the question would be express area in terms of circumference, that part, okay? So that is how you could express this. So in short, you could actually, let me expand this also. So we get pi times c square 4 pi square, right? So pi will cancel. So we get area as a function of circumference is equal to c square divided by 4 pi, correct? So that formula can also be used at times, and it helps, in many cases when the circumference is given to you and you need to find area of a circle. This formula can be used, okay, this is the formula, right? So either one of these formulas could be used for circumference as a function of area, correct? These formulas are very important if we have to maximize the area, right, or minimize the circumference or the perimeter of the circle. In all those questions, you need to relate one function in terms of the other function, and with such manipulation, you can do so. I hope you understand and appreciate it. go through this series to learn how we can do the same thing for three-dimensional figures. Thank you and all the best.